Have you ever wondered why we exist? Why the universe did not annihilate itself in a burst of energy just moments after the Big Bang? This riddle has puzzled scientists for decades, and it all boils down to an intriguing imbalance. You see, for every particle of matter born in the fiery genesis of the universe, there should have been an antimatter counterpart. Antimatter, the mirror image of regular matter, carries opposite charges. When matter and antimatter meet, they annihilate each other, releasing energy. Yet here we are in a universe filled with matter. So what tipped the cosmic scales in favor of matter? This is where hyperhelium-4 enters the picture. This exotic particle is a member of the antimatter family, and understanding it could be the key to unlocking the secrets of the universe. To unravel this cosmic mystery, let us delve into the fascinating world of antimatter and one of its exotic constituents, hyperhelium-4. Antimatter, a term straight out of science fiction, is as real as the device you're using right now. It's the evil twin of matter, identical in every way but with an opposite charge. Antimatter is the rarest, most energy-packed stuff in the universe. When antimatter and matter meet, they annihilate each other, releasing an unthinkable amount of energy. It's a wonder of nature that's as fascinating as it is elusive. Now, let's shift gears to a peculiar helium isotope, hyperhelium-4. Picture a helium nucleus, but with a twist. It's got one or more hyperons, particles that are even more massive than a neutron or proton. These hefty particles give hyperhelium-4 some unique properties that scientists are just beginning to explore. Just when you thought the universe couldn't get any weirder, say hello to antihyperhelium-4, the antimatter version of hyperhelium-4. The discovery of antihyperhelium-4 was a breakthrough moment in the world of physics. At the forefront of this groundbreaking discovery was the ALICE collaboration at CERN, the European Organization for Nuclear Research. Here, scientists were able to uncover the first evidence of this elusive antimatter hypernucleus. How, you may ask? By colliding lead nuclei at the Large Hadron Collider, the world's largest and most powerful particle accelerator. As these particles smashed together at near light speed, they produced a quark-gluon plasma, a state of matter thought to have existed just microseconds after the Big Bang. And within this plasma, scientists spotted the antihyperhelium-4. But that's not all. This discovery falls perfectly in line with the standard model of particle physics. For those unacquainted, the standard model is our best description of the fundamental particles and forces that make up our universe. And within this framework, the existence of antihyperhelium-4 was predicted. This discovery was not just a triumph of experimental physics, but it also shed light on the matter-antimatter asymmetry in the universe. So why does the discovery of antihyperhelium-4 matter, you ask? Well, it's akin to finding a new piece in a cosmic puzzle that scientists have been trying to solve for decades. This discovery is significant because it aligns with the standard model of particle physics, a theory that describes 3 of the 4 fundamental forces in the universe. More notably, the detection of antihyperhelium-4 confirms the accuracy of the statistical hadronization model. This model, my friends, describes hypernuclei production in quark-gluon plasma. That's a fancy way of saying it explains how certain atomic nuclei form under extreme conditions, like those found during the first microseconds after the Big Bang or in the heart of neutron stars. Speaking of neutron stars, this research could lead us to a better understanding of hyperon interactions within these celestial bodies. Hyperons are a type of subatomic particle, and knowing how they behave in the densest, most extreme environments could unlock new insights into the nature of matter itself. So the next time you gaze at the stars, remember that there's more out there than meets the eye, and the discovery of antihyperhelium-4 is a testament to that.